Welcome to the next lecture on derivatives. So, in this lecture we will be learning about rate of change of quantities. So, in this lecture we will see application of derivatives to calculating rate of change of quantities. So, here what we have is let t denotes the time and let x and y be two quantities depending on the time t. So, x and y are functions of t. So, x is some x of t and y is also a function of time t. Now, suppose we are given y as a function of suppose we are given y as a function of x. Now, the rate of change of changes of x and y are the derivatives dx dt and dy dt of x and y with respect to time t. So, by rate of change of a quantity we mean the derivative with respect to time t. So, if dx dt, that is the rate of change of x, is known, then the rate of change of y dy dt can be calculated using the chain rule as follows. So, we know that y is given as a function of x. So, dy dt by chain rule can be written as dy dx times dx dt. So, if y as a function of x is known, we can calculate dy dx and dx dt is the rate of change of x which is assumed to be known. So, then dy dt can be calculated. So, let us look at some examples. The first examples, suppose it is given that the radius of a circle is increasing at the rate of 3 centimeter per second, find the rate of change of the area of the circle when the radius is 10 centimeter. So, what is given is here that the radius of a circle, this is increasing at 3 centimeter per second, and we have to find the rate of change of the area of the circle when radius is 10 centimeter. So, what here we have two quantities, one is radius and another is area. So, we know that area of the circle, let me write A, is given by pi r square, where r is the radius of the circle. And then what is given is that the rate at which radius is increasing, it is dr dt, is equal to 3 centimeter per second, and what we have to find is what is dA dt when r is equal to 10 centimeter. So, we know that dA dt is equal to the derivative dA by dr times dr dt. A is given to be pi r squared. So, dA dr is 2 pi r times dr dt, and dr dt is given to be 3 centimeter per second. So, this is 2 pi r into 3 centimeter per second. So, dA dt when r is 10 centimeter is 2 pi into 10 centimeter times 3 centimeter per second, which gives 2 times 10 times 3 is 60 pi centimeter squared per second. So, this gives the rate at which the area is increasing. The area is increasing at 60 pi centimeter square per second when radius is 10 centimeter. Let us look at next problem. So, here we are given the volume of a cube is increasing at the rate of 8 centimeter cube per second. Then the question is, how fast is the surface area increasing when the length of an edge of the cube is 12 centimeter. So, again let us see what is given and what we want. So, let x be the length of an edge of the cube, then volume V is x cubed. The volume of the cube is the length of the edge cubed, and surface area, let me write this as A, this is equal to 6 times x square, because there are 6 faces of the cube, each is a square of side x. So, we are given volume and surface area in terms of the length of the edge of the cube, and then what is given is the rate at which volume is increasing. So, dV dt is equal to 8 cubic centimeter per second, and we have to find the rate at which surface area, that means dA dt. What is dA dt? When x is equal to 12 centimeter. So, if you see in this problem, we have actually 3 quantities which are depending on time. One is x, another is the volume which is x cubed, and surface area which is 6 x square, and we are given dV dt, we want dA dt. So, if you look at this expression for V equal to x cube, since V equal to x cube, dV dt will be equal to dV dx times dx dt, this is by chain rule, and dV dx is 3 x square times dx dt. Now, we are given dV dt, so we can calculate dx dt. This implies dx dt is equal to 1 by 3 x square times dV dt, and dV dt is given to be 8 centimeter cube. So, this is 1 by 3 x square times 8 centimeter cube per second. So, now we know what is dx dt, and we have area, surface area is a function of x. So, if we know dx dt, we can calculate dA dt. A equal to 6 x square, this implies dA dt is equal to dA dx times dx dt, and dA dx is 12 x times dx dt we have calculated is 1 by 3 x square times 8 centimeter cube per second. So, this can be simplified and we get x cancels and 12 by 3 is 4. So, this is 32 divided by x centimeter cube per second. So, therefore, what we have to calculate, what is dA dt when x is equal to 12 centimeter is equal to 32 by 12 centimeter cube per second. So, this is equal to 8 by 3 centimeter square per second. So, thus the surface area is increasing at the rate of 8 by 3 square centimeter per second when x is equal to 12 centimeter. So, in this problem we saw that we have two different quantity depending on x, and each depends on t, and then we had to calculate. If we are given the rate of change of one quantity, we can calculate the rate of change of the other. The third problem that we will do, here we have a rectangle and we are given that the length x of a rectangle is decreasing at 5 centimeter per minute, and the width y is increasing at 4 centimeter per minute. Now, when the length x is 8 centimeter and width y is 6 centimeter, find the rates of change of A, the perimeter, and B, the area of the rectangle. So, let us see what is given. We have a rectangle and let us say its length is x and width is y, and we are given dx dt. Note that here it is given that the length x is decreasing at 5 centimeter per minute. So, since x is decreasing, dx dt is negative. So, this is minus 5 centimeter per minute, and dy dt, the width is increasing at 4 centimeter per minute. So, this is 4 centimeter per minute. Now, let P and A denote the perimeter and the area of the rectangle respectively. So, what we have to calculate is what is dp dt and da dt when x is. So, to find dp dt and da dt when x is equal to 8 centimeter and y is equal to 6 centimeter. So, what we know is that the perimeter is equal to 2 times x plus y, 2 times the length plus width, and area is x times y. So, therefore, if we calculate dp dt, this is equal to 2 times dx dt plus dy dt, and dx dt is given to be minus 5. So, this is 2 times minus 5 plus dy dt is 4 centimeter per minute. So, this gives us minus 2 centimeter per minute. Thus, the perimeter is decreasing at the rate of 2 centimeter per minute. Now, for area, A is equal to x times y. So, dA dt, here area is product of x and y. So, by product rule, this is equal to dx dt times y plus x times dy dt. Dx dt is minus 5, this is minus 5 y plus dy dt is 4 x. So, therefore, the rate at which area is changing when x is equal to 8 and y is equal to 6, this gives minus 5 times 8 plus 4 times 6, sorry, minus 5 times 6 plus 4 times 8. So, this is minus 30 plus 32. So, this is 2 centimeter square per minute. So, the area is increasing at the rate of 2 square centimeter per minute. Okay, so, the next problem is there is a spherical balloon is being inflated by pumping in 900 cubic centimeter of gas per second. Find the rate at which the radius is increasing when the radius is 15 centimeter. So, what we have here is we have a sphere. So, the volume of the sphere is given by 4 by 3 pi r cube, where r is the radius of a sphere and v is the volume. What is given is the rate at which volume is increasing dV dt, this is 900 centimeter cube per second, and we need to find what is the rate at which the radius is increasing, that means dr dt when radius is 15 centimeter. So, since v is equal to 4 by 3 pi r cube, dV dt is equal to 4 by 3 pi times 3 r square and then dr dt. So, this is equal to 4 pi r square dr dt. We are given that dV dt is 900 centimeter cube per second. So, therefore, dr dt is equal to 1 by 4 pi r square times dV dt, which is equal to 1 by 4 pi r square times 900 centimeter cube per second. And then we have to calculate this when r is 15 centimeter. So, when r is 15 centimeter, dr dt is 1 by 4 pi times 15 centimeter squared times 900 centimeter cube per second, and this gives 900 divided by 4 pi into 15 into 15 centimeter per second. So, we get this is equal to 1 by pi centimeter per second. So, the radius is increasing at 1 by pi centimeter per second when r is 15 centimeter. Let us look at another problem. So, here we have a ladder (5 meter) long, which is leaning against a wall. Now, the bottom of the ladder is being pulled along the ground away from the wall at the rate of 2 centimeter per second. So, the question is how fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall. So, let us try to understand this problem. We are given a ladder 5 meter long. So, let us say this is wall and this is the ground. We have a ladder, this length is given to be 5 meter, and let us say at some time x is the distance of this foot of the ladder from the wall and y is the height of the ladder on the wall. Now, what is given is this bottom of the ladder, the foot of the ladder is being pulled away from the wall at 2 centimeter per second. So, this x given dx dt is equal to 2 centimeter per second. Because it is pulled away from the wall, x is increasing with time. So, this is with positive sign, and we have to calculate to find dy dt when x is equal to 4 meter. So, when the ladder is pulled along the wall, this x is increasing and y will be decreasing. So, dy dt will come out to be negative. Now, how do we find this? Let us see what is the relation between x and y. So, we have, because we have a right angle triangle here, by the Pythagoras theorem, x square plus y square must be equal to 5 square. So, if we differentiate this with respect to time, differentiating with respect to t, we get 2x dx dt plus 2y dy dt. Right hand side is constant, so the derivative is 0, and this implies that dy dt is equal to minus x by y times dx dt. So, you can see from this equation that if x is increasing, dx dt is positive and then dy dt will be negative. Now, when x is equal to 4 meter, what is y? Y is equal to square root of 5 square minus 4 square. So, this will be 3 meter when x is 4 meter. So, therefore, when x is 4 meter, dy dt is equal to minus x is 4 meter divided by y is 3 meter times dx dt, which is given to be 2 centimeter per second. So, we get this is equal to minus 8 by 3 centimeter per second. So, the height is decreasing at the rate of 8 by 3 centimeter per second. Okay, let us look at another problem. Here we are given a particle moves along the curve whose equation is given as 6y is equal to x cubed plus 2. We need to find the points on the curve at which the y coordinate is changing eight times as fast as the x coordinate. So, we are given equation of the curve and we need to find points. So, to find x comma y such that dy dt is equal to 8 times dx dt. So, from this equation 6y is equal to x cubed plus 2, this implies that 6 dy dt is equal to 3 x square times dx dt, which implies dy dt is x square by 2 times dx dt. Now, we need to find this x y such that dy dt is 8 times dx dt. For that, if dy dt is 8 times dx dt, this implies that this factor x square by 2 must be equal to 8, which implies x square is 16. So, x has to be plus or minus 4. Now, we need to find the y coordinate also. So, when x is equal to 4, y is equal to x cubed is 4 cubed plus 2 divided by 6, which is 64 plus 2 divided by 6, 66 by 6, that means 11. So, y is 11, and when x is equal to minus 4, then y will be minus 4 cubed plus 2 divided by 6, this is equal to minus 62 by 6 or minus 31 divided by 3. So, the required points are 4, 11 is one point and minus 4, minus 31 by 3 is another point. Okay. Now, this rate of change is also used in economics. So, let us look at application of rate of change. In economics. So, suppose x is the number of units of an item produced by some industry. So, x is the number of units of an item produced, and C of x denotes the cost of producing x units. So, this will depend on the number of unit, the cost that the company has to spend on producing x unit, that is C of x, and R of x, this denotes the revenue obtained by selling x units of the item. So, that means that what is the amount that the company will obtain if they sell x units, that is R of x, and then of course, profit is revenue minus the cost. This again depends on the number of units x produced and sold. Now, here there are some terminologies which are used. So, marginal cost, say MC of x, this is defined to be the rate of change of C of x with respect to x. That is, when we write marginal cost, which is a function of the number of unit x, this is equal to the derivative of C with respect to x. Similarly, the marginal revenue this will denote by MR of x. This is by definition the derivative of revenue with respect to x. So, again if you see that we have to calculate marginal cost or marginal revenue, then we need to take the derivative with respect to x. So, for example, suppose the total cost C of x in rupees for producing x units of an item is given by C of x is 0.007 x cube minus 0.003 x square plus 15 x plus 4000. So, this formula is given that the cost incurred for producing x unit is given by this formula. Now, what we have to do is we have to find the marginal cost when 17 units are produced. So, all we have to do is we need to take the derivative of this cost function with respect to x. So, marginal cost at x is dc dx, which is equal to, you take the derivative of this. So, x cube will give 3 x square, this is 0.021 x square minus derivative of x square is 2 x, so 0.006 x plus 15. So, when x is 17, we need to calculate the marginal cost when x is 17. This is 0.021 times 17 square minus 0.006 times 17 plus 15. And this is 0.021 times 289 minus this will give 0.102 plus 15. And this, I think if you calculate, get 20.967. This is the marginal cost. Similarly, if revenue is given, so the next example, the total revenue obtained by selling x units is given by R of x is 13 x square plus 26 x plus 15. Find the marginal revenue when x is equal to 7. So, again if you know the definition, marginal revenue is the derivative of r with respect to x. This is equal to 26x plus 26. So, therefore, when x is 7, this is equal to 26 times 7 plus 1, 26 times 8, which is equal to 208. Now, suppose we want to maximize the profit, then what should we do? So, we know that profit P of x is the revenue R of x minus the cost C of x. Now, to maximize the profit, therefore, if we take the derivative P prime x, this is equal to R prime x minus C prime x, which is the marginal revenue minus the marginal cost. So, in order to maximize the profit, the number of units x should be such that the derivative P prime x is equal to 0, that is marginal revenue of x should be equal to marginal cost of x. So, if we equate the marginal cost and marginal revenue, so by equating the marginal revenue and the marginal cost, we get the values of x for which the profit is maximum. So, we will stop here for this lecture, and in the next lecture we will see some more applications of derivatives. Thank you.